And the equation is based on, earlier we said, this, right? So you have the first discount rate, the lower discount rate. So basically I'm following this equation. Okay? So the lower discount rate is 10%, right? Plus the NPV1 is the positive NPV 105.18. Okay? And again NPV1 105.18 plus the absolute value of the negative NPV, which is negative 1688.91. So the absolute value of this becomes a positive number. That whole thing, right, times the difference between the R2 and R1. Right? So 12% minus 10%. So that's basically the equation, right? Once you already have this one positive and one negative NPV and discount rates with a positive and negative NPV. And so if you solve for this, this becomes actually 10% plus 0.0586 times 2%, which is the difference between these two, you get something like 10.11%. Okay. That's the IRR of Diana. Now for the project Zeta, you don't have a positive NPV, both are negative at 10 and 12. So you need to try a lower NPV, a lower discount rate, say at 8%. So at 8% NPV, well, I'll spare you the computation. At 8% discount rate, the NPV is positive 1,215.84 for project Zeta. So again, you apply the same equation for the IRR of Zeta using one positive NPV at 8% and then the other negative one. Don't choose the 12% because it's too big. Choose the 10% discount rate, right? Because you want it to be closer together to zero, as close to zero, right? So the second one is 10%, which we said the NPV is negative 597.29. So that's what you computed in part A of the exam question. So this is the only thing that's new here in part C, is you compute the positive NPV. So at 8%, Zeta has finally a positive NPV, right? So again, you use the same equation earlier, this one, right? So you compute 8% is R1, this is R2. So label it correctly. So 8%. Okay, plus, again, NPV1 is 1,215.84 divided by NPV1, again the positive NPV 1,215.84 plus the negative NPV is negative 597.29, but you again take the absolute value of that, so this becomes positive. So you just basically add them up. And times the difference between 10% R2 minus R1, which is 8%. So that's the there, what you will get is basically, 9.34%. So this is the IRR of project Zeta. Okay. So what decision will you make? Based on a hurdle rate, you say you have a hurdle rate of 10%. Well, that means Yana passes, right? This is okay. I'll accept Yana at a 10% hurdle rate, so it's greater than your hurdle rate. But I will reject Zeta because it is less than your hurdle rate of 10%. So again, you have to state that clearly, to make sure that, they know you have answered the question and evaluated it based on the correct criteria of the hurdle rate, right? So don't just compute these two, make a conclusion, right? Do you accept or reject which one? Okay, is that clear? Alright, so that's the answer. 10.1 for Yana, 9.3 for Zeta. So you accept Yana because it's greater, it has a IRR greater than the hurdle rate, right? And then reject Zeta because 9.3 is less than 10%. Okay? Now, then we continue, right? So the same two projects, how about we evaluate it using the third kind of method, which is the payback. Now, the payback period is the super simple method of just simply adding up the cash flows to see at which point can you actually get paid back your initial investment, right? So you just basically add up all these cash flows as you go along. At which point can you reach 50,000, or at which point can you reach 45,000, right? In which year do you get paid back, right? Kind of a very simple kind of rule of thumb type thing that you can do when you're in a store. You decide, oh, I get paid back on this X number of years, right? If you don't have a calculator, you can just add up your expected cash flows. But your criteria, your company's criteria is they only want to accept projects that pay back within 2 years. So the rule is the cutoff period is 2 years. So which of these projects will pay back in 2 years? So this is the payback method. You just accumulate your cash flows, just basically add them up to find out at which point are you paid back. After that, up to which point you get 50 or 45,000 back. So the answer here is, if you add up all those cash flows for Yana and Zeta, you need more than 2 years to get back the 50,000 for Yana. And you need more than 2 years also to get back the money, the 45,000 for Zeta project. Therefore, if your cutoff period is 2 years, both projects won't cut it, basically. They won't pay you back within 2 years, so you can't accept those two projects if you use this method. Okay, so as you can see, it's a really very crude, simple method. Maybe for non-finance people it makes sense. but it's too simple, right? You just reject both of this because it doesn't look like they're gonna pay back in 2 years. All right? Now, again, the question continues, right? So they ask you advantages and disadvantages of the payback rule. You're expected to, of course, say advantages and also say the disadvantages, but you're expected to say bad things about it, right? So because you're a finance person, you know that this payback rule is too simplistic and not good enough, okay? So although you can mention advantages, simple, it's good when you don't have enough capital, you need to get your money back within 2 years really, right? So there's a bit of allowance for risk because in a way you're accepting projects that pay you back sooner. But the downside is, what does it ignore? Time value again, right? It doesn't even know that basic finance rule that money that's later is less valuable than the money today. But when you just add up the cash flows regardless of when you receive them, because here you're just adding them up, you're ignoring the whole concept of time value of money. You're giving equal weight to cash flows that are even, 2 years from now versus 1 year from now or today, right? So you're not discounting the future cash flows. That's not good enough. It doesn't consider time value. Now also, it ignores the cash flows after the cutoff period. What if in year 3 you got like 100 million, right, in one of these projects? No, you don't care because your cutoff is 2 years. If it doesn't pay you back within 2 years, you reject the project. So it ignores cash flows beyond the cutoff period, which could be sizable, right? So it could be really a worthwhile investment if you get millions 3, 4, 5 years from now for putting in 50,000 only. So again, it just prefers shorter lived projects. Okay? The ones with short lives, they can pay back sooner. Okay? So these are the 2 key things you're expected to explain. Of course, this is just a summary. You're expected to highlight these 2 key points. Right? The payback is not good enough because it doesn't include time value. It ignores cash flows after the cutoff date. And then also again, the same question continues on. This time, evaluate the IRR method, the internal rate of return. Okay? What are the limitations of that method? Okay? So again, you need to touch on a few key points, right? So it doesn't maximize I'll just show it so that there's more time. Wealth, as we said, shareholders' wealth. You want the shareholder to, the owners basically of the company, to increase their wealth. That's their goal in investing in the company. And IRR may not maximize that. You may look like you have a high return simply because your initial investment is low, but in the end it may not give you more cash flow. You're just looking at return, which compares the initial investment. So a small initial investment project would give you a high return, but in cash flow terms it doesn't give you as much. So you're looking at it as a percentage return when you look at IRR, but for NPV it gives you the absolute value in dollar terms. How much money does it bring in? So that's the main problem with the IRR method. Okay. Another problem is there are certain projects with cash flows especially those that have positive and negative cash flows over time, that could give you multiple solutions, meaning several discount rates, maybe 2 discount rates could give you an NPV equal to 0. So which one do you use, right? So we're looking for NPV equals 0, right? What discount rate will give you an NPV equals 0? But if certain cash flows could give you several discount rates that will make your NPV 0. So you have several IRR, which doesn't kind of make sense. Or you may have no solution. There's some patterns of cash flows where you can't find a discount rate that will give you an NPV equal to 0. So that again, there's no solution. Another thing is an implicit assumption when you're making this IRR method is that you're reinvesting these cash flows using the same IRR. Right? But in reality, you don't go out in the market and get that same IRR as your project, right? For similar risk, you'll get the opportunity cost of capital as the amount that you can get in the market. Right? So that, again, that assumption is unrealistic, that you can reinvest the cash flows using the same IRR. The more correct assumption is you can reinvest it using the opportunity cost of capital, which may not be the same as the IRR. Okay. Now, better answers would use a diagram. So again, PDF is a totally handwritten exam, right? So you can draw diagrams, right? And that would help you explain things. So again, feel free to draw certain diagrams like we showed in the lecture notes, right? So for some of these points, we did show some charts, examples of how, the IRR's limitations are. Now, another kind of question, and we've been talking about this quite a bit, is the opportunity of capital, cost of capital. What do we mean by that? Right? So you need to explain some key points. One, that is determined by the market, comes from the capital markets. It is the return you'll get in the market for projects with the same risk. That's why it's your opportunity cost, because you could put your money in that investment in the market instead. Right? So this is how much return you could be getting if you put your money in the market for projects with the same risk. So that's why it's kind of an objective measure. That's how much you get in the market. So some key points, it's market determined. Second key point is risk. So it's for projects with the same risk, right? How much return you'll get in the market. And this opportunity cost of capital is what we will use to determine the discount rate. So this is the discount rate we'll use, to compute the present value, to compute, to discount the future cash flows using this. Because this is the return we would have gotten if we put our money in the market. So we kind of discount those cash flows using this same opportunity cost of capital. So this is a good way to make a decision in, because you know that you have considered other investments out there with the same risk. Now, I mentioned also a benefit of NPV being the additivity, that you can add up all of these present values, right? NPV. Okay. So, so you can read up on this. This is the expected outline of your answer. $25,000. And then project Y, that's packaged along with it, has actually a negative 20,000 NPV. But if it's packaged together, it looks like, oh, this is a good project, but it has a 30,000 NPV, right? 30,000. It would, if people package them together, right? But if you separate them out, you know, this is 50, this is negative 20, you don't invest in Y, right? You can separate out, and we can't like deceive you by packaging them together. If you have to buy, also you have to invest also in Y when it gives you negative. Any questions? Okay, now let's look at valuing bonds and stocks, right? Or maybe we should take a break. All right, I think we can take a break.